did back in the summer of '94. And so you can see a whole bunch of buttons here. And let's just look at what some of these do. Notice that here we have axial, sagittal, coronal. If you're not familiar with this jargon, then this is the orientation of a slice. From a 3D volume in the head, slices like this are called axial. Okay, slices like this direction across the top of from the nose to the occiput are called sagittal. That goes with the sagittal crest. That's how I remembered it when I first started. The sagittal crest is the grade 8s have. I guess we're not grade 8s because we don't have one. But up here, and then and this one is called coronal, which is like face on. So axial is horizontal, or sometimes is also sometimes called horizontal. It's like just because if you're standing, that is horizontal. Although when you're in a scanner, it's vertical actually, right? So then sagittal and coronal. So these things open up image viewers to look at images in these standard orientations. And they pull the data out of the 3D volume based on how it's stored on disk, so that it can be flipped around in various ways. As long as the header file has it oriented correctly, it should draw these out in this kind of view. So I think I'm going to close these, everything but the axial image because of this limited screen space. If you use this stuff a lot, you find imaging in general a lot, you find you want bigger monitors. A postdoc in the lab next to mine, Peter Vanetini's lab, just got a 49-inch monitor on her desk, which everybody's going like, she's going to a faculty position in 6 months. Can I have her monitor? Came in a box this big, which is about her height. So I said, "Wait, just ship yourself off to Dartmouth." You can get that with that fun. A little kid would love it. When you were a little kid, would you have loved a box like that? Anyway, so I'm going to close these windows. You can close the windows using the interface the operating system provides with the button, or I can close it with a button here at the bottom, which is in red. Which is, click on that, we'll close it. The button is labeled done. In general, these buttons that are labeled red are that sort of the most active button in a window. And so here in the AFNI controller, done. If I press this, it will close the AFNI controller and the program. I'm not going to press that. Well, I'm going to press it. You'll see what happens. It changes to all caps. Because closing AFNI after you have everything set up the way you want is kind of a major decision because you may have to go, oh my God, what did I do? So now you have to press it twice within 5 seconds. It goes to all caps, and if you don't do anything 5 seconds later, it will go back. That's because I discovered very early when I was programming this that I was accidentally clicking it when I didn't want to, and I was then swearing at myself a lot. So, and I said, well, I'm writing the program, I can make it do whatever I want. Or whatever I can figure out how to do. So here's an AFNI image viewing window, the axial image. This is showing, actually it looks really nice on that screen as opposed to this. That screen's got more contrast than mine. So this here is an axial image viewer, and the features you see are these crosshairs, right? These green crosshairs. If you don't like the green color, over here there's a controller that says color, and we change below X hairs, there's a controller that says color. We can change the color of the crosshairs from this menu, which is often useful depending on what the brightness of the underlay image is. If the underlay image is really bright, this grayscale image is really bright, you may want a dark color, or vice versa. The program doesn't try to guess, it just starts with some color. So those crosshairs, why doesn't it have crosshairs? Well, let me open up the sagittal view again for a moment. The sagittal view shows crosshairs also. These are corresponding crosshairs. That is, the crosshairs intersect at the same point, which here is near the base of the brain. And if if I use the left mouse button, I'm using a mouse, which is very handy with AFNI for me, maybe because I'm an old easy type kind of guy. but the click the left mouse button. It's easier than the trackpad in my opinion. But I click the left mouse button here. Say back in what's called the splenium, this little knob at the back of the corpus callosum, and the crosshair moves there in the image window I click, and the other image window jumps to the same location. They're slaved together. They cannot be unslaved. Because I found early in AFNI that if you unslave them, it becomes very confusing very spatially. And so, to me, and so therefore you have to live with that. But so, here, for example, in the axial window, I have this crosshair that runs vertically from the top to bottom, right? One of the hairs in the crosshair. That's the slice plane for the sagittal, right? And then I have a horizontal one, and that's that horizontal one running from left to right in the axial window corresponds to the vertical crosshair in the sagittal plane, because that's a crosshair. That's the cut plane for this. If the coronal window was open, which would be vertical, right? So that the location that the crosshairs meet is in the AFNI documentation, sometimes called the focus point, because typically that's the point you're looking at. That's the point you want to draw if you're making a figure out of it, either you're drawing someone's attention to it or you're drawing your own attention to it. And the coordinates in the data set are given in the upper left corner of AFNI window. Here, you see that? So it says x equals this, y equals that, and it says y equals 25 point something p for posterior. That makes this posterior of the middle of the coordinate system. It's backward. In medicine and science, you can't use single syllable words. It's not, you're not a real person if you use single syllable words. And z is here, 18 is positive, so it's superior. This coordinate system is in the same. Then we'll come into this debate of coordinate systems. Coordinate system here is in the same order as the DICOM coordinate system, where negative x is right and positive x is left. And negative y is anterior and positive y is posterior, and negative z is inferior in the body and positive z is superior in the body. But in typical neuroimaging literature, neuroscience literature, people don't use DICOM coordinates. They use what they sometimes call cleverly neurological coordinates, which is of course a meaningless phrase, but that was full of meaningless phrases. You can set that here, so that is this order, the second order. If I right click, that's what having a 3-button mouse is handy. And if you're using a Mac or something, that means you have to press one of the keys on the keyboard or click on the right space on the trackpad, depending on what kind of version of the thing you have. But if I right click, I get a pop-up menu and I choose the second one, and now I get a different, now I get the coordinate, where the x and y coordinates, the signs are reverted. The x in the neurological coordinates, which is the same that SPM popularized, runs from left to right, left being negative, right being positive, and so on. So basically that coordinate system is rotated 180 degrees. So if you're going to report in tapers, almost always you report in this coordinate system. And you can do that easily because you can switch the coordinates around in AFNI. Inside, AFNI works in DICOM coordinates. So, I'm going to close the sagittal image again and so let's go to some questions to make you actually think here, as opposed to just consume this entertaining monologue. And that is, here's an image window. How could you change the brightness of this thing? I'll give you a hint. There's some buttons along the right side of the image viewer. I call this whole window the image viewer. There's some buttons along the right side.
Oh, C.
C and B, contrast and brightness.
Oh.
So if you click, very good. If you click C up, it should change the contrast kind of dramatically. If I click B down, it changes the brightness down. Like that, for example. Now, so if I screw it all up, I get it really weird. What can I do to fix that? Make it normal.
Take a norm, I guess.
Norm! Like for the actor, the character in Cheers, or the people in Norman, for example. Norm. Wasn't thinking of that. Norm makes it normal. That's the default setup. It may not be what you want, but at least if you really mess it up, you can get it back to something that's usually tolerable. Now, we work with a guy named John Buttman, who's a radiologist, who's a guy I really admire at the NIH, and he was saying, oh yeah, in radiological systems, they don't have films anymore usually, it's all computers, right? And I said, oh, to change the contrast and brightness, you don't have buttons. What you do, you take a mouse, and you can do this on the trackpad, but it's a little trickier. But you take the mouse, with a mouse, and you click down. If I left click down and release, it jumps the crosshairs like I'm doing right now, right? Click. If I take the mouse, press left click down and hold it down. Keep it pressed down. And then drag the cursor location left or right. You can see it's changing brightness and contrast. Actually, it's changing one brightness and contrast. I drag it vertically, it's changing the other one. Which one? I don't remember, and I wrote the software. Because I don't need to remember. Because I can just drag it around so it looks good. Now maybe I should drag it around so it looks good for you, not for me, because the contrast on the screens is somewhat different. There, that looks pretty good. Drop it. Just unclick when you're done. So it's the motion. If you click without motion, then that means move the crosshair. So if you click, hold, and move, it does something completely different. So that was relatively easy to do, and I did it to please him because I like him. And he's a nice guy. And it's a lot easier than these C and B buttons, which were there for like 15 years or something before someone suggested a different way to do it. Okay, so let's have another quiz. Suppose I drive this image window to be bigger, like that. So now there's a bunch of unused space in the image window. How can I expand the image part of the image window to be bigger? It's another button on the right side. This will require experimentation, perhaps. Don't be afraid of the graphical interface. My wife is an incredibly intelligent woman. She's definitely afraid of graphical interface. I'm not going to click on that button until you tell me what it does. What? I, which stands for image fraction. If you click I up, the fraction of the image in the window gets bigger. At one time, I tried to make this automatically adapt, and I failed because it would like get into a war with the window manager. On some systems, you'd change the size of the interior image, and it would change, and that would cause the image, the whole window, the window manager on the system would change the size of that, and then it'd go back and forth into an infinite loop, which, well, if I had any hair, I'd pull it out. So anyway, you can adjust that as you please. Then, how would you zoom? Yeah, Z, I think, is pretty self-explanatory. Z. Zoom. That's a zoom a factor 2, a factor 3, and a factor 4. Those are built in. There's no continuous zoom. There's no, besides these 4 levels. The image looks kind of blurry here because, of course, I've made the image bigger, but I don't have any more data, right? I love these things on TV where they have like this grainy picture of a crowd, and they zoom way in on somebody, and you see them beautiful, like it was taken with an SLR, like 3 feet from them. I said, those guys have good software. My favorite of all time was one where they had the picture of the back of someone's head and used that to reconstruct their face. And rotate it around and identify him from a database as a terrorist. I thought, that's really good software. A little better than we have actual technology for. I'm pretty sure it's hard to reconstruct someone's face from a picture of the back of their head. Much less than get a good enough one to identify it from a database. That was good software. They have that. Well. So this is blurry looking and grainy because of the noise in the image, which is now magnified in scale. And but we're zoomed in, and we happen to be looking right here in some ventricle stuff. There's a button that was activated below called pan. Pan is not the Latin word for bread, and is not the for a pot you cook things in. It means like camera panning around. So if you click on pan, then the cursor should change shape to this hand, and you click and drag, you can drag it around to see the port, looking through this portal of the image window onto the zoomed image to get it to the front. Say for some reason you love this gyrus sulcus here. It's beautiful. This is where, you know, your whole PC thesis revolves around or something. So you may want this kind of thing. And then if you zoom back out, if you zoom all the way back out down the one-to-one zoom, then pan button is disabled. It's still there, but you can't click on it. It won't do anything. And below that is a button called crop, which can be useful if you want to crop the image for this before you like save it to a file or something like that. Of course, you can always crop it afterwards too. You know. Typically, if you're producing an image for production, we're putting in a paper or something, you'll produce images in the AFNI and save them, but then you'll probably post-process them in some graphics editor to put captions on and maybe try to make them look a little better or something like that. But we don't really do that because I don't want to spend all my effort competing with Adobe or something. They have more budget than I do. So that's the stuff on the right side of the image viewer. Let's do one more weird thing, one more weird diet trick. Right there, I drag the window, and now the image has got a weird aspect ratio. The program, this happens. I won't complain about why this happens, but it happens. So this happens. To fix this, there's a bunch of different ways. The simplest way is to take the cursor, or mouse, or trackpad, move the cursor over this bar that runs vertically next to the image from black to white, and just left click on it like that. And then that renormalizes what's called the aspect ratio, the ratio of horizontal to vertical, so it maps to the physical, so the person's brain doesn't look like it's been squished or stretched. Which can be amusing, but isn't really very useful. This bar, while I'm at it though, this bar, if you put the cursor over the bar, you should get at the bottom of it a little pop-up thing. And you may find that hard to read on the screen there, and I find it hard to read, but it says on mine, at this instance, it says 0.56 to 1144. This is the mapping. I mean, the data, we call it an image, but it's really a bunch of numbers, right? This is the mapping from images to color intensities on the scale, on the screen, which in this case are grayscale colors, but they're technically there's no colors. And so this is the mapping. If you click this button at the top, it says swap. That just turns the intensity bar upside down, and now the 0.56 now maps to white. Is this useful, this swap? Not very often, but it was there because this original viewer in AFNI is derived from an earlier program I wrote called FD2, which only double slices, but it was which was itself adapted from another program called FD, that's the FD2, and had this swap button, which some people liked at the time. And if you want to be really fun, you can change it so instead of being a color grayscale bar, it's a color bar, which I admit that you have to admit that looks nice, right? Is this useful? Seldom. But if you're trying to make artistic stuff, it's kind of fun. But in any case, image viewer. I'm supposed to end in 15 minutes, so let's accelerate this process. The image viewer has a whole bunch of other features which I'm not going to go through, but at the bottom there's there's two that I want to cover. One is this button here, Mont. Mont means montage. Click on Mont if you please. Mont. If you click on Mont, the top pops up a little controller. That's what these buttons on the bottom do, is they pop up little controllers that let you do more things, rather than just do stuff directly like these other buttons do. These buttons pop up little controllers where you have to give more information. So here the information is, we'll make a montage, more than one image. Right now we're showing, you might call it the minimal montage, one image by one image, one slice by one slice. So I can choose across, how many slices do I want to cross? So let's say 5. And down, let's say 2. So I don't completely fill up my screen in a horrible way. And then how far apart are they? Well, let's leave that at 1 right now, and just click draw. So now we see these slices, and they're almost the same. And it becomes a little more obvious what's going on if I choose open one of the other image viewer windows. Let's say coronal, just to be clear. I choose either one, the perpendicular one. And you can see this is the crosshairs in that window have changed to show that I have all these slices like this. But these slices are next to each other. They're spaced 1 apart, which is 1 millimeter, which isn't very, the brain doesn't change a lot in 1 millimeter, so that's why they all look the same. If I want to make an array that covers the brain, I have to choose the spacing more cleverly. I don't know what it is off the top of my head, or my head, or this person's head. So I'll change it to 6, say, and see what it looks like. In physics, the jargon for this is the slice package, which is, I think, a nice term. But so 6 isn't quite big enough to be big enough for the whole brain or the upper part of the brain. 9, maybe. And then you have to click draw, and then you click, say, there to put the center of the slice package there. Now you're starting to cover the brain, and then you can play with this. So you can play with this, and you can scroll through now. You can still click in these images and move around as you like. It's often more convenient when you have a montage to click in one of the perpendicular viewers, though, which makes it a little more clear where the slices are. And you can put borders between the sub images, like so make it 2 pixels thick and make it what's a nice color, pink. Now you can do that if you really want. Not many people actually use that feature though, but pink is such a nice color. Who would want to? Well, you can just choose the border. Choose the border to be 0, in which case it doesn't occupy any space. So this is, at this point, then, you can save this image. If you want to save this image, for some, say you're going to make a Christmas card out of it. You might do other things, but I can't think of any off the top of my head, so we'll just say you're going to make a Christmas card. The crosshairs will be saved too. It saves the image as you see it, more or less, as well as it can. And the crosshairs, I do this all the time. I save the image, open it up to make sure it's what I want, and then I say the crosshairs, I go, what an idiot, pow! And then I save it again, so I'm just telling you that you have to turn the crosshairs off almost all the time. Some people like the crosshairs if they're going to discuss it in the figure caption, which of course your Christmas card always has the Christmas captions, right? I mean, figure captions for your Christmas card. So we click here to turn the crosshairs off. Back in the AFNI main controller, there's a button here just below the coordinates that says X-hairs, which is short, of course, for crosshairs. And there's modes for the crosshairs. Multi is the default mode. Single means it will, even when the montage is on, it will only show one crosshair. You see that in this coronal window now, it's only showing one crosshair, even though I have multiple. That's the single crosshair. I can just turn them off too. Now there's no crosshair. If I want to save this now, then I come over here. I want to save this montage. It says a button that's next to Mont, to the left of it, here, says save one.jpg. So that will save it in JPEG format cleverly. You can change the format. There's 2 ways to change the format. I'll show you both. Let me close this. Montage control window. The first way is if you click on this button. I had to close that in order to be allowed to click on this button at the far left at the bottom. It says disk for display, and you get a whole bunch of options for how you control how the display works. the interface works, which I'm going to ignore almost entirely, but in the middle here, you see there's various ways to save the image. And you can save, the default is saved to JPEG, but I could save it to several other formats, like PNG is also a popular one these days, or you could save it to a TIFF. Of course, you can always convert images externally, and one of about 400 million programs that people have written. So that's up to you. I'm not going to change that. The other way to change it, though, would be to right-click on this Save One JPEG button. It would pop up, if you can right-click somehow. It will pop up a little menu with the list of options. And the list of options includes Save, JPEG, all these others. And at the bottom it says Save MPEG. You can actually, if you have a time series, you can save movies. But I'm not going to go through that. That'll be something you can learn on your own. But if I just left-click on this button as usual, it gives me a little, what do you want to call this file? I would call it something, right? So I'm going to call it Fred, because I like the name Fred. And then I can there's a blow-up button here. I can have it magnified inside the program by a factor of 1, 2, 3, and so on. Because these are actually relatively small for the purposes of printing or something like that. Of course, you can always blow it up inside another program too. If you have, so it all depends on how you're gonna deal with the image later, right? Say open in GIMP. Anyone here know what GIMP is?
Yeah.
If you not, GIMP is it stands for GNU Image Manipulation Program. And if AFNI, when it starts confined to GIMP on your system, it will give you, you'll see this line here, and then if you click yes when it saves it, it will immediately open it in GIMP, so you could edit it in GIMP. GIMP is like to call themselves the open source version of Photoshop. It's not really as capable as Photoshop, and it certainly its interfaces and it's slick. On the other hand, it is free and runs on Unix, which is two things that Photoshop doesn't do. So if I click on, I'll just leave this like this: blow up one, don't open in GIMP, and if I click apply, these buttons at the bottom. Quit means just close this little controller window like it never happened. So cover up. It's a cover up. Destroy the evidence, right? Apply means do it and leave this window open. In this case, that's not probably very useful. And set means apply then quit. That's the one that's hotified here, because that's the one that's the most consequential button in this little sub window. Set. There you go. And it says it wrote out in the text in the terminal window that we started in. It tells you what it did. Wrote out writing 933 by 512 image to file Fred.jpg, and which presumably is in the directory here. Open Fred.jpg, which is a Mac thing, and we see it opens it in preview, the default image viewer, and there it is. So it succeeded. Exciting. I expected it to succeed. After all, if it didn't, I would have fixed the bug. So, close this to put AFNI back to the front. That's the AFNI image viewer. I have 5 more minutes, and now I'm going to switch. I'm going to turn the montage off on this baby. Montage off. To do that, I open the montage button again and click one by one, 1x1 at the bottom. I mean, you do that by setting across and down to 1 each, but this is just as in one step, that's all. I turn the crosshairs back on because I want them back on. I'm now going to switch the underlay. This is a subject's T1 image. If here you see a button here that says underlay. Underlay is the grayscale image, and Paul, I think in the next session will talk about the overlay, but I want to show you one more thing in the underlay. Click on the underlay button, which is in black, and it shows you a list. It shows you a list of all the data sets that are open, that AFNI open, and is ready for display. So, and that was the first one. Why did it show that first? Because it's first in the alphabet. That's why. If you had something that started with the AAA, it would be shown first. Like the AAA. So the next one is called EPI R1. That's EPI run 1. And as we get into the analysis of this, we'll find there were 3 runs. three separate runs of data, but was just showing one in this directory. And this is EPI run one. If you notice down here on the right, it says EP and 3D plus time, and it's 152 time points. So that means that, this is just some little tiny fragment of information from the header to help you remind you of what the data is. Because after all, I'm telling you this because you've never seen the data. If this was your data, you might remember it. But if it was data, you inherited from her when she got her PhD and went away to her great career somewhere, and then you, poor new graduates, didn't get your advisor said, oh, take her data and analyze it. It won't be that hard. And then you can, limber up your story. Yeah, but this will tell you, this is an equiplanar image, and it has the 150 time points. I click on that, and that becomes the underlay. That's the default mode of operation, I think now, is you click and it switches immediately. So in space, these things don't look so exciting, right? Unlike the T1s, which I think are frankly remarkably interesting. But on the other hand, they're not meant to look good in space. As I said, they're meant to look good in time. But when I have time, I can make graphs through time, right? Like I had in that image that I showed in the talk. If I click on a graph button, well, what do I get? A graph. Shocking, but true. And this graph window, this is a graph. Let me change the crosshair color because that's really bright. Change the crosshair color to dark blue to make it a little more apparent. And I'll drop the brightness down a little bit. You can see the, maybe you can see it better now. The crosshairs is changed to a box here. The intersection of the crosshairs is changed to a box, indicating it's 3 voxels on the side, in the underlay volume in this slice we're looking at. And those 3 voxels are graphed through time in this graph window that I opened. And I can drag this to be bigger or smaller as I choose. And the time point I'm at is the time point that I'm at, both in the image and the graph, is indicated here where it says index. Remember, subword counting starts at 0. I'm right now at the 0th index because that's the first one and it doesn't know any better. Now you can change that. You can type in a new number here. You can click on this, or you can take this. See the red dot here? In this central graph, which is outlined in a little gold border, that red dot indicates where the current time point is that we're looking at. I can go click on this graph somewhere and it will jump. So if I click on that, if I click on that point, the red dot jumps, the index changes to 78, for example. Why 3 by 3? That was the default. We can change that. There's a menu item for that. On the lower right corner, there's a menu called Opt. I click on Opt for options. And then Matrix. This is called the grid matrix. I can click on Matrix, and I can either move the matrix up or down, or just set the number with this little menu here where it says 3. These things in square brackets are keyboard shortcuts. The graph viewer has a lot of keyboard shortcuts because after you get to use it for a while, keyboard shortcuts are a real fast way to do stuff. At the beginning, they seem opaque and stupid. And then after you want to do something for a while, you realize it's a keyboard shortcut. Your fingers fly across the keyboard, and everybody thinks she's got mad. So little m, lowercase m, changes the matrix down by 1 to, I can't make it smaller than 1 by 1 because that would be kind of pointless. I'm not sure what it would mean, actually. But this is often very useful if you're like looking at some place and things are weird and you want to get a close view of it. Here's one weird fact, is the first volume here in time is way bigger than all the others. This is a common thing. It's called the pre-saturation artifact, among other things. It indicates that the very first volume in the time series is weird compared to all the others. And so that almost always, for the viewpoint of fMRI erosion, the changes in the data caused by subsequent to neural activity, caused by blood changes, caused by neural activity, causing MRI signal changes. This MRI signal change is not neuronal. This is a physics artifact. We don't want that. So almost always when you analyze fMRI data, one of the first things that gets done somewhere along the way is the front gets chopped off. Usually the front one, sometimes the front two. Depends on the scanner though. Siemens does that for you automatically if you have a Siemens scanner. And if you don't want it to do that, you have to tell the Siemens scanning system to turn that feature off. GE, I don't think does that for you automatically. So this is something you need to know. How do you know? Well, one way is you have Siemens or GE scanner. Another way is open AFNI and look at it. If it looks like this, they didn't cut it off, right? So there. That's one thing, and now it's time to stop. But Paul is not doing his duty. I'm a whole minute over, and it's he's not going like this. But I'm going like that. So I'm going to stop now, and we'll have a 15-minute break, and Paul will just continue at some point with the AFNI graphical interface and driving it from outside. You can write scripts to do this stuff too.